We'll start. So good morning, everyone. My name is Arthur Guichet, Secretary General from the European Water Association, and I will be your moderator today for our first Direct Alpine Space Margin project on a webinar on groundwater challenges in urban area. So I will start with a few presentation, a few slides about EWA, and the rules from today, and then we'll start that straight with the first presentation. So the European Water Association, we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries as national members, corporate members and research members. As one of our research members is actually the Technical University of Munich, with where we are working together on this project. We aim to be a platform for key discussion on technical and policy issues in Europe for our members. And in order to do so, we arrange several events, conferences, workshop, meetings. We have special working group of experts, education and media activities. So you have our website. I will try to keep it rather short. House rule for today, as participants, you can either use the chat as you are currently doing to say hello to everyone. That's already great. And please use the Q&A box and the Q&A function to submit your question to the panelists via this button. We cannot switch on your mic and camera, so please use the Q&A so all the panelists will see the questions. When you do so, please also mention to whom your question is addressed to. And this event is recorded and you will receive the presentation after it as well as the link. So I will stop sharing, and again today is again on about the margin project, which is groundwater challenges in urban area, managing groundwater sustainability in urban area. And our first speaker will present you or give you an overview about the margin project, and will also talk about the activity of the city of Munich into the project. And our first speaker is Dr. Kai Soseda, your senior researcher and head of the Geothermal Energy Group, chair of hydrogeology at the Technical University of Munich, also associated head of the chair. You are an expert in swallow, deep geothermal and aquifer thermal energy storage, and you lead major EU and national projects such as FlexGeo, GeoBoost, Safea, GigaM, Speicher City, and you are also coordinator of this Interact Alpine Space Margin project. So Kai, the floor is yours.
So thank you for the introduction, and I will share my screen. I hope everybody can see it now. So thanks for the introduction and also for the possibility to talk here about the issue of groundwater challenges in urban areas. So first of all, what you see here at the first picture is some typical problems what we have. On the one hand, we have flooding in cellars. On the other hand, we need clean groundwater for drinking water or industrial purpose or whatever. And on the other side, what can happen is also that the wells where we use the groundwater in cities are dry. So that's what we experience at the moment. And I will give you a short insight about the general problem of groundwater challenges in urban areas and some of the preliminary results, what we did in the Margin project. So the Margin project deals with managing groundwater sustainability in urban areas. So what we see is that we need more managing of the groundwater and also how we use it in a sustainable way. So what we want to do is to quantify the vulnerability of groundwater quality and quantity. So how vulnerable is it? And especially what are the causes, why we do that? It's of course what we see climate change effects and urbanization impacts on groundwater. And what we want to develop is good adaptation measures for the cities to be prepared for the future challenges. That's the framework of the Margin project, but now I will give you an insight about what are the motivation for it and why we're doing it. First of all, urbanization. Of course, urbanization, why we put urbanization here in our scope. It's of course one of the major challenges what we have. Urbanization is since mid 2007, 50% of the world population is has been living in cities, and it will be more and more in the future. Of course, we have a demographic change, so around 90% of population growth up to 2030 will take place in the cities. So this is where we have a lot of developments also. So the city development, 50% of the cities over the year 2015 have yet to be built. So there will be a lot more development, a lot more urban structures around the world. And these cities needs a lot of resources. So 75% of energy and resource demand is linked to the cities. And of course, groundwater is one of them. And also what we have is that the decisions on the city has a long-term impact. So what we have in urban infrastructure, like drinking water pipelines, heating pipelines or whatever, this is really a long-time constant. So all decisions, what we made on the city developments, also for sustainable cities, have a long impact on the one side, but also these long-term or these urban infrastructure needs also a long time to change. So we have to do something now to change for the future challenges. And of course, climate change is hitting the cities quite a lot. So the cities are responsible for approximately 80% of the human-produced greenhouse gases emissions worldwide. And on the other side, of course, climate change is impacting the cities a lot, for example, for the urban heat island effect. Of course, in cities, the underground in cities are very, very used quite well. So we have drinking water resources, we have infrastructure, we have thermal use, and. So a lot of uses take place in the urban underground because we need so much resources. So there is a conflict of how we deal with the underground, and groundwater as a part of the underground, of course, is linked to that one. So we need to manage these conflicts quite a lot better. So these underground multiple function, that's a key issue, and what we see that it's getting actually a lot more and more used. Also, what you can do is you can link all these underground use to the Sustainable Development Goals to develop the world in a sustainable way, and what are the different sub-goals and how it is linked to the underground. And just what you see is a lot of these Sustainable Development Goals are, of course, linked to cities and also linked to underground structure. So industry, for example, or also clean water, of course, but also sustainable cities and communities, of course. So that's quite a lot of Sustainable Development Goals, and a lot of different aims for a sustainable future are linked to underground and to cities. And this is why it is so important to think about it and to deal with it. What are the challenges for the groundwater in detail? Of course, I start with climate change. You may know that, everybody, so that the change of intensity and temporal distribution of precipitation is, of course, influencing quite a lot the groundwater. So we have droughts, heavy rains, we have change in snowmelt input if you go more in the alpine regions and whatever. So this impacts a lot the groundwater. So we have changes of groundwater recharge, so linked to groundwater availability, how much groundwater is available. We have groundwater extremes, high and low levels. This may impact also on the infrastructure and the city infrastructure. So amount of groundwater is changing, and groundwater temperature, for example, as well. This is linked also to groundwater conditions. On the other side, don't forget urbanization, because urbanization is, of course, also overlaying climate change impacts on groundwater at some point. So we have increase of ceiling, we have underground infrastructure building quite a lot, as explained before. We have an increase of the urban heat island effects, increase of groundwater use, and then of course we have change on local groundwater levels because of this urbanization. We have change of groundwater temperatures because of the urbanization, and also groundwater availability changes. So this also impacts and overlaying these different changes what we see in cities. And this is then hard also for analyzing and creating tool, what effects, what is the question a lot in the cities. So we have some risks and some conflicts. So we have conflicts and decrease of availability. We need the resource as drinking water, but also as industrial water or for thermal purposes because of our energy transition, what we need also for a sustainable city. So the resource for renewable energy and heating and cooling will increase, and groundwater can be one of the promising sources for that. But also we have damage on building and infrastructure through these changes, and also change of the ecosystems can be happen. So a lot of risks what we have in future, and these risks were before there, but we see an increase of these risks because climate change and urbanization is quite developing. Of course, what is the consequence? We need a management of the resource in a much better way. So we have to see what is a sustainable use of the resource. This is needed, that we guarantee the services in the future, drinking water, but also energy. And of course, what we need is adaptation and mitigation to climate change and urbanization effects, that we can, of course, then guarantee a sustainable use. That's the main challenge what we have. So looking at the cities, and just a short picture about it. Of course, we have all these different infrastructure. We have these pipes, infiltration. We have the cellars and buildings in the underground. We have drinking water purposes. We have processed water and then ecosystem as well. So all these must be considered in a city management of groundwater. Of course, all these cities and municipalities have generally not the focus on the groundwater in the city administration planning. That's what we see. So different departments are linked to groundwater issues, but this is not in the focus of the cities so far. So what we see is, and what is our hypothesis and experience, they are not really prepared to future challenges concerning the groundwater resources and why we want to work out. What we need for a good management is, of course, data of the different aspects. We need data from groundwater, but we need also data from the infrastructure and. So a lot data is needed to face the groundwater challenges. And of course, for the data analysis, we need methodologies. There are different methodologies around. Some are used, some are not used. Some are really shaped to the challenges, some not. So we need new methods, but also good practice methods. And then based on these methods, we have to develop strategies for the cities. There are also some strategies in place, like sponge city concepts and, but are they linked together? Are there really a comprehensive strategy for the cities? And we say this is not often happen. So we identified hot topics in the project of margin. One of those is, for example, groundwater extremes. Well, that's one of the hot topics for cities. So we have high and low levels. High levels lead, for example, to flooding terrain, flooding cellars, also can lead to land subsidence. And also the low levels can lead to negative influence to infrastructure, for example, dry wells. This is one of the examples. So we have to manage the groundwater extremes. On the other side, we have a rainwater infiltration, so sponge city concepts. So this is linked totally to groundwater recharge management and also groundwater recharge quantification assessment, and also on groundwater quality issues. So it's a good concept, of course, and for several reasons, for well-being in cities and but what is the consequence for the groundwater at the end? That must be managed. We have the thermal use of groundwater, so this is very important for city heat planning. And what we see also that which information do we need? We need low and high groundwater temperatures. What is the groundwater temperature distribution in the city? How can we use the groundwater? And is there an interference in the use in the thermal groundwater use, or maybe also in the use with other purposes like drinking water or whatever? So we need an interference management here to manage this in a sustainable way. And of course, groundwater quality plays a big role here. We have groundwater ecosystem, hydrochemistry conditions, of course, contamination. That's quite very well known for cities. And also groundwater temperature is changing, and we have to manage and we have to identify how this will be developed in future. So these are the topics what we identified in the project by talking to different cities. In the project, we have 4 cities: Linz, Ljubljana, Milano, and Munich. We were working on. We have several other cities where we, which are not partner cities, but we were working also with these cities as well. So, and based on these city analysis, we identified these topics. So going more in detail, so we have these 4 cities, and we looked at the cities, what is a specific interest? And I don't want to go into detail here because we have several topics like flooding cellars or groundwater temperature, also groundwater use and low groundwater negative influence. And we asked the city, what is of high importance for you? And just what you see is it could be quite very different based on what the cities are already doing, but also what is of the interest of cities. And what we realized is that, of course, the cities have a specific interest and they want to know something and want to deal with it because there is a lack of knowledge and also some gaps for measures and management. On the other side, we think sometimes it is also necessary to raise the awareness for some topics on the cities which they are not aware of. So if this is a negative influence of low groundwater levels, maybe can impact your groundwater use in future. Are you aware of? This is what we want to work out and really raise the awareness for the cities. Is it a topic for you? But what you see is the topics could be very specific, but there is some common topics which the cities have always. Of course, so that's just a very short overview of the topic. So I want to go in one topic for the city of Munich, and that's the thermal groundwater use, just to show you a little bit what could be done and what is necessary to do for a management in the topic of thermal use of groundwater, for example. So what we have in the city of Munich is what you see here, the thermal use. So a lot of systems are already implemented and they need to manage. And of course, in the terms of energy transition, what we need sustainable and renewable sources. Groundwater can be one for heating and cooling. We have a lot of systems implemented. They use a lot of groundwater, but we have to manage this, of course, because it's increasing use, so we have to manage it. What we need is a dynamic optimization between heating and cooling, for example, and. So, of course, what we did is we integrated also in energy action planning. Why I'm saying that? Because this means we have also to interact with different departments in the city, and what we not did maybe before in groundwater issues. So these are new departments and new stakeholders came in where we have to communicate with, exchange data, and. So what we did here is, of course, we developed, and there was an energy action plan or municipality energy plan developed for the city of Munich, and we did a potential analysis. What we need for that one is, of course, a lot of data and analyzing of borehole data, of drilling data. We have to analyze the groundwater conditions, of course, quite a lot. What is the hydraulic conductivity? Which information do we have? Where are pumping test analyses? And on the other way is we have, of course, to identify what is the groundwater table, and for this issue, for example, what is the groundwater table at low level, because if we want to use the groundwater for thermal use in a sustainable way, we have to plan on low levels, because it must be available also if the groundwater levels go down, also for future planning. So we need a very sustainable planning and sustainable information about low levels. Also on the distance to surfaces, because that if we inject water, do not get a flooding cellar or whatever. So it's quite a lot of what we need here. And of course, groundwater temperature must be analyzed. We did that here with a lot of analysis, and this take a while. We did that together with the city of Munich. But of course, a lot of data is needed. That's the message here. Of course, what we did that also, we did the aquifer basement. So the aquifer basis is calculated, and then we calculated the aquifer thickness, and then we how to use then groundwater heat pumps here in that way. So we did a quantitative potential analysis. That was the requirement. So that was not a methodology there so far to assess it. So the only picture, I don't want to go in detail here, but what we did is we developed a methodology and a tool. And this must be done for several requirements and challenges if this methodology is not there yet. And we have to prove methodologies and see what we can do. So we did this methodology. I don't want to go into detail. You can read it in our publication anyway. And at the end, we distributed, or we analyzed the spatial distribution of the technical withdrawal rate. And this was then for different systems with different distances. And then at the end, we integrated that in the energy action plan that's now available. So this is one part, how we can deal with this and how do we manage. And at the end, we also developed a thermal groundwater management tool for a sustainable management. Well, that's just one part, and it's not linked to other issues. And this is what we have to look at. What is the main challenge? The main challenge is, of course, data availability. We need the data. What you see here is we did a large data analysis, which data are available in the cities. And if you have yellow, of course, it is medium available. So, and if you have red, it's not available yet. And what you see is, for example, construction sites or buildings or whatever, all these data are generally not available in cities. So we need information about groundwater conditions and all groundwater related data like infrastructure. So we need the information about data which can influence the conditions, but also which can be affected by changes. And that's also a future challenge. And I don't see a lot of cities who have these data already available. So there are more than the data, just to see a lot data, and some are green, most of them are yellow. So there are a lot of improvements. So what are the main gaps? And I want to say the main gaps are what we see is a fragmented governance. So the data is not really got managed, and that's the main thing and the main gaps what we see. Also that we have not shared data, that we have a lack of monitoring and a lack of tools. That's a message here. So also the management of the governance. So what we see is that we have a lack of governance, as I said before. This is a main outcome. So we need a clarity of mandates and responsibilities. We have to assign or to consider legal and procedural alignment. We need an interdepartment cooperation and visibility, because the data are laying a lot in different departments, and that's a main challenge. So we have to see how to manage that further. We need a stakeholder participation and transparency, because some data, what we need for good groundwater management, are outside of the cities. So we have to see how do we get the data and how can we exchange and use this data. Also, institutional capacity and resources are important, and the integration into the broader city planning, that's the main issue. So I just give you very roughly some ideas about what we did for the Munich city. So we analyzed it, and what we see here, if we just take one topic out and say rainwater infiltration and response city, what you see, a lot of departments, different departments of the city are involved. So they have to exchange information, exchange data, analyze the data in one way, and actually then give the information back. And that's a main challenge. And I haven't seen a city where this is very well developed and very well managed. So you see, a lot of what we do here is how to deal with response city concepts. And what I see with all these institutions, they have to change and to communicate and a lot. So a lot of errors in different directions, and this need managed somehow. And for another thermal use of groundwater, what we did in Munich, you see again all different institutions, even more because it's quite very, very linked to planning and so this must be very well managed. And this is for me the main challenge what we have in the cities, that the data governance and management has a lot of gaps. So what is the conclusion? The conclusion is, of course, that the groundwater is on different departments. A lot of departments are involved, also other regional and national institutions. So we have to see how can we do it better and what are the main topics here. For me, that one of the main topics is we need a collection and digitalization of groundwater data. So data must be available for the management and also for all other related data for groundwater management, like building basements and because this is not what we have at the moment. And there's a lot of lacking information. So what would be a central management will be good, where all relevant data and information is collected, analyzed, and available. So we need a good governance of this data and a good governance of the tools and the methodologies. So based on this data, actually, we need a vulnerability and risk assessment, and this is needed. We need methodologies, good practice methodologies. We have to exchange these good practice methodologies with other cities and city departments, and we need tools developed which are accepted and which are for practical use in the cities. So also the tools can be very sophisticated depending on the data availability, or can be basic, but should lead to the challenges. And of course, then based on this risk assessment, we have to develop strategies, adaptation strategies, and these strategies must be linked, because concept for sponge cities must be linked to a concept for low and high groundwater levels for construction sites and. So this is what we see, what is not happening at the moment, that these strategies are not linked, and that is the challenges for the urban cities, for urban groundwater management, because that's what we see, what are the lacks. So I hope to give you and this is all what we want to do in the Marching project, and to do some concepts, to analyze that, and to find solutions for a better and improved groundwater management for sustainable use. Thanks a lot for listening to me, and I'm looking forward to your questions if you have one.
Thank you very much, Kai, for your presentation. So for our participants, please use the Q&A button function to ask your question to Kai. And thank you very much. Nice introduction. Good to see what's happening on the ground into the project, as that's not really EWA part of it. We'll move now to our next speaker, Cornelia Steiner. You are a geologist at Geosphere Austria, formerly GBA, specializing in shallow geothermal resource assessment and spatial energy planning. You are coordinator of Austria National Geothermal Atlas. And in margin, you lead the work package 2 on citywide risk assessment and adaptation strategy with prior coordination roles in Interreg and Horizon projects. and your impulse will be focusing on challenge and first result in a pilot city of Linz. Just a quick information, we are having issue with our third speaker. So if you see only three of us here, it's normal. So we are trying to sort this out. So we hope it's sorted out before it. But first, Cornelia for the pilot city of Linz. Cornelia, the floor is yours. And we can see your screen, so everything's fine.
Perfect. Thank you. So I'm happy to tell you about the challenges and the first results we have in our Austrian pilot city, and this is Linz. So I hope, yeah, here we go. So Linz is the capital of Upper Austria with around 214,000 inhabitants, an urbanization rate of around 60% that already shows growing urban concentration. It is also impacted by climate change with a temperature increase by around 2.1 degree above the industrial levels. And as you already heard in Martin, we look on these urbanization and climate change effects on the groundwater. So let's see how the regional hydrogeology in Linz looks like. Here we have two quaternary gravel aquifers, the Welser Heide and the Linzer Feld. They are mainly recharged from the two rivers, the Traun here in the western part for the Welser Heide and from the Danube in the Linzerfeld in this area. These aquifers are used for drinking water supply, for irrigation and industrial use, as well as for heating and cooling. You can see on the map the groundwater heat pump installations in the pilot area. These are about 1,200 installations at the moment. Below these quaternary aquifers, there is an aquitard system, so something that does not let water flow through. This is the so-called Schlier. It consists of very fine-grained marine sandy clay, and this protects a second groundwater body, which is below that, and these are the Linz sands, also fine-grained sediments with a lower hydraulic conductivity than the above gravel aquifers, but they are important for future drinking water supply because they are well protected from by this Schlier from possible contamination. So let's see what challenges that we have here in this hydrogeological setting in Linz. So, and I hope I get the slides back to moving. Here we go. The first challenge I would mention is that we still have partly analog data handling, unfortunately, in the city of Linz. And regarding the management of thermal groundwater use, this is becoming more and more important because the numbers are growing. And related to this, it would also be important to know more about the potentials and resources that we actually have here in Linz. This means also it would be good to know more about the groundwater temperatures. And regarding the groundwater ecosystem, here we also have some data gaps. And the data gaps are also related to the Linz sands. Here, it is important to know more about the extent and depth of this confining Schlier layer to ensure future protection of this possible drinking water aquifer. Okay, so how can margin actually contribute to solve these challenges? Let's see what we have come up with. We worked this out together with the city of Linz and also the Linz AG, our project partner here, and with other relevant stakeholders. So we already heard from Kai that data is often fragmented in the city, and we see this for Linz as well. For example, when we look at the list of observation wells, here we have multiple sources. And in the margin projects, we want to bring this together and also update this list to see if these observation wells are still in operation, if they are still accessible. And that's what we actually already did. And how did we do this? We went out into the field and check if these wells are still accessible. And we did this in the frame of our groundwater temperature analysis, where with our team that also includes the University of Vienna, we headed out to measure around 400 observation wells, where we documented the water level and the groundwater temperature every meter going down to 1 meter above the bottom of the well. And in some of them, we also took the electrical conductivity. And we did all this to interpolate this groundwater temperature map. You can see the first draft here with the measurement points. This already shows us that we have higher temperatures more in the city center, and some of the higher temperatures are also located here in this industrial region. We were going to repeat these measurements in April to document the colder conditions, because the first one was done in October, which reflects warmer groundwater conditions. And with this repetition, we can also see this, learn more about the seasonal changes in the groundwater temperature. And this is an important input for the estimation of resources for thermal groundwater use. We have already seen a methodology, how this can be calculated, and we are going to apply this methodology here in Linz. And it's also planned in a later stage to also look at the heating and cooling demand to analyze the demand coverage. I cannot show you more here because this is work in progress. Coming back to our field measurements, you can see here also some first results from the electrical conductivity, which we use as proxy for the groundwater quality. The biological characterization is also important for the groundwater quality. And here was also a second field campaign done in a smaller patch of observation wells. In 30 wells, groundwater samples have been taken and analyzed for the groundwater chemistry and biology. And in some of these water samples, you can already see the groundwater fauna without a microscope. So here you can see, for example, some groundwater amphipods. That's how you scientifically call groundwater shrimps. And we have a first analysis of this data here in this graph, where you can see the actually 6 different groundwater fauna groups that are crustacean, and then 2 worm-like groups. They are distributed very heterogeneous over these samples. You see some of the water samples had a lot of individuals in there, and some of them just only a little or none at all. The identification of the specific species is still work in progress. And the goal here is to really get a comprehensive picture of all the organisms that are present. And that's pretty good, because such comprehensive assessments are very rare. And last but not least, I'm coming back to the Linz sands that I mentioned in the beginning. Here it is important to keep this Schlier layer that is here in this yellow blue color. This is our protection layer above these sandy sediments. And this should remain intact. And so it's important to not drill through, and to to avoid this, it's also has to be known how actually thick this Schlier layer here is. You can see in this cross section that this varies a lot. In the northern part, it's rather thin, and then the thickness increases. And to find out more about this in detail, we go through the borehole drillings that are available and geological cross sections to model the bottom of the Schlier, and this data can then be used by the city of Linz. Yeah, and when we prepare all of this, we are always in constant exchange with the other pilot cities. So this is the reason why we did margin, so that we can learn from one another. And with this knowledge, we will then be able to support Linz as well as the other cities in their efforts to address the groundwater challenges related to climate change and urbanization. So that's our plans for Linz. Thank you very much.
Thank you very much, Cornelia, for your presentation. So once again, do not hesitate to use the Q&A function. I will try to see if Isaac, you are now muted. And I hope soon unmuted and will be able to do to join us via the phone. Isaac, has to unmute. I hope it will be working. No.
Okay.
Hi,
Hello.
Isaac. Yes.
Morning. Do you hear me?
Yes, we hear you. I will share my screen. I think you see it via Caroline on another online platform. And
Yes, yes.
we thank you
Yeah.
for your dedication.
Yeah, sorry very much for the technical problems. Apparently, Zoom doesn't, well, the commission doesn't like Zoom. But thank you to Caroline. We managed, to find a solution. For me, it's quite new. It's the first time I'm doing this on the phone. But good. Yeah, it's always good to try new things. So, well, first of all, good morning to everyone. All the webinar participants. And my focus, the focus of this presentation is to give an overview of the groundwater directives. Okay, so first of all, just a quick introduction from myself. I'm working in the unit C1 of the DG Environment. We are responsible for the water framework directive as well as we showing here, the total directives, groundwater directive, and environmental quality standard directive. It's the surface directive and the flows directive. But in this first slide, I want just to give a quick overview of what is all the interlinkages, for the water framework directive. So I will talk a little bit later about total directives and the revision that it's now on the table to be reviewed. But you can see also that there is some legislation in yellow that has been already reviewed, like the Urban Wastewater Treatment Directive on the table, and the Drinking Water Directive, it's the recast of 2020. Evaluation, so just to make emphasis that the evaluation is a different step, a previous step for the revision, for everyone to have it clear. So first there is an evaluation on the table, and then management decides if it goes to the next step, to the revision, or they say no, it's okay, it's still fit for purpose and doesn't need to go further to revision. So you see now in the evaluation that we have on the table the nitrate directive, a little bit, there are different issues, but we want to have straightforward, streamlining, and simplification, with other directives. For example, water directive was in evaluation and it has been decided not to go forward. So this is an example of not to go forward. And the Marine Strategic Framework Directive is in evaluation and it has decided to go forward for the revision. Okay. So I will concentrate after in the one on orange, the Water Framework Directive and the Groundwater Directive. So please to the next slide. So just a quick overview of the Water Framework Directive. It's from 2000. It's a cornerstone of the EU water policy. Just to recall, the first recital that it's the water is not a commercial product. We recognize that it's obvious that it's a lot of subsidiarity to the member states of the water issue. And And Article 2 talks about the division, yeah, how the units that they are measured. So it's the river basin unit. So all the catchments of the rivers is where the divisions are made, and this is the approach. Yeah, obviously there is a consequence of this regarding the groundwater, because the groundwater, the aquifers go underground, and they don't have divisions from catchment. So there is an administrative division for groundwater bodies, and these normally the member states manage or feed them within the catchment areas of the river basin districts. Okay. Article 4 is the most important. It's the one that describes the objectives, but also Article 8 because of the monitoring. But important to have it clear here. So there are like two objectives for surface water. Yeah, the first one is surface water, and the second one is groundwater. Two objectives for each. The one, surface water, good ecological potential. So there are quality elements that are included there, like biological, also physicochemical, morphological, and the chemical status. And for groundwater will be the quantity and the chemical status. Just to make emphasis that the two chemical status objectives, it's what it's found, all the provisions are found in the daughter directive. So in the case of surface water will be the EQSD, and in the case of groundwater, it will be the groundwater directive, just to remind for the chemical status. And article, the different sub-articles for 4, for 7 are all the exemptions that the member states can make use of to come in for the objective. So, for example, now in 2027, so all these exemptions will come up to an end. Yeah, so I'll say Article 9, just to mention the economic aspects as well are considered. Please, next slide. Well, this is just some other provisions regarding water in the Water Framework Directive. I will pass the presentation, so yeah, you can have with you. Maybe after you can share it afterwards. So please go to the next slide, because I think it's more important. Yeah. So here I focus on the Groundwater Directive, and well, yeah, different articles as well. But I want to concentrate in Annex 1 and Annex 2, that are more or less the ones that are kind of the most important, because describe which are the pollutants that the member states have to comply with, and which are the quality standards or the thresholds. Yeah. So in our terminology, of the directive, quality standards refers to values, that threshold values that the member states have to comply with. So this is EU-wide, and it's obligatory. So this is threshold for all the member states. So as you see, there is only 2 pollutants in the list: nitrates and the pesticides and the relevant metabolites, with the quality standards. Threshold values is the same; it's a synonym of the quality standards, only that there is none in the Groundwater Directive, and then it's the member states who, considering that there are concerns regarding one groundwater body, they have to put a threshold, that is the one that they consider they are appropriate for this pollutant. And this part B, in the last part of the slide, it's a list of the pollutants, that the minimum list that the member states have to consider when they see there is a concern, in the water bodies that they see a concern. Please, next slide. So, I want to just quickly talk about, it was already a revision of this Groundwater Directive. It was in 2014. It was very, well, it's just a few elements were revised, but mainly was an incorporation of agricultural, diffuse pollution products, nitrites and phosphorus, in the list of pollutants. So in this Annex 2 Part B, so the ones that the member states can put the thresholds, and also the member states establish the thresholds. Please, can you go to the next one? And importantly, in this recital 2, you don't have to read all this. Yeah, it's just to let you know that here in this recital is where the seed was put in the water framework, in the groundwater directive to introduce the watch list. So the need to have a watch list of pollutants, which the member states have to collect data, because it is the objective of the watch list. We don't have still enough data. We don't know if it's EU-wide a concern. So the member states will put this in the watch list, these pollutants, the ones that they consider. We have to, of course, have a prioritization exercise, and then monitor in order to collect data, so that Commission can consider if this is a EU-wide problem, and then put quality standards. This, as I said, it was only the seed, and it was performed as a voluntary basis until now. So this is important. Yeah? Voluntarily since 2014 until now. That it's the revision that we are going on and having for the list of pollutants. Can you go to the next slide, please, Arthur? So here is where I introduce. I'm going to talk about the revision of the list of pollutants. So it was there are both in the Water Framework Directive. There are obligations for the Commission to revise the list of pollutants and the quality standards periodically every 6 years. So that was a proposal. Commission came up with a proposal to revise this, which was adopted by the Commission in October 22. You can see that it already has passed a lot of time, almost more than 3 years. Went through the Parliament, so the Parliament has to agree. It was voted in plenary. You can see that it was largely supported. We had more problems with the Council. As you can see, we went through 7 presidencies. Some of them more engaged than others. And at the end, the result of this is that they vote in a general agreement in Coreper, and it was in 2024. After that, it follows by a trilogue. So the Parliament, Council, and Commission agree on the final text. And this was already, the agreement was reached in September last year. And it's foreseen that it appears, so it enters into force, what we call in the official journal of the European Commission, of the European Union, this year. We foresee that this will happen in March 20, this year. Okay, just to highlight that this was a very technical, because of very technical file. And that's why it has been delayed so much, because because of the problems of finding the presidencies to take up the file. This slide is just to show you graphically how what implied this proposal in changing. So it implies changing Groundwater Directive and the Environmental Quality Standards Directive, surface water, and of course the provisions that are linked to the mother directive, that is Water Framework Directive. So everything that is related to this directive, to the original one. Please, next slide. So here, because we already have an agreement from the trialogues, I'm just going to highlight which are the changes that are concerning this agreement in comparison with the original proposal of the Commission. That was, as you remember, October 22. So Commission, first of all, wanted to speed up the process. So we wanted to have delegated acts, so something that we don't have to consult again all the European Parliament, the Council. Instead of having ordinary the normal track, so ordinary legislative procedure, we just wanted to have a little bit more speed up process, because, as I said, the technical dimension of the file. But this has not been seen good by the Council, so we keep the ordinary legislative procedure. Then there is a longer transposition period for the new pollutants, so 2027 will start. it was managed to December 27. It seems like a key date because it will mark the transition period. It will mark the start of the monitoring program, as you see the fourth line. By December, and will be also the start of the fourth reporting cycle of the river basin management plan. So they managed to fit everything on the same period. In the third line says that member states wanted a longer compliance deadlines because of they have problems with the cost, administrative burden. So some of the pollutants will start complying from 2023 for all the new pollutants and the new quality standards. But if we add all the exemptions that are two reporting cycles that will end up, it was a negotiation, 1 or 2 monitoring cycles, but 39 or 45. And then there are some other the 1, 2, 3, 4. The sixth line says something that the member states wanted to introduce, so they wanted to have some more facility to have a temporary deterioration or relocation of pollutants. So we introduced this ad hoc. It is not originally from the Commission proposal to for the member states. And the last line says some about the transborder recuperation. So there were some disasters like the other river disaster that we wanted a more coordination, more information sharing about a more speed up for cooperation between the member states and also information for the Commission. Please, next slide. So main changes in the groundwater directive. Basically, so as I said, watch list now goes from voluntary to now obligatory. So it will align with the surface water, which was already obligatory before. Okay, and this watch list of pollutants. Then ECA, the European Chemicals Agency, will have an important role here because it will be in charge of submitting reports and also to consult their scientific committees, on economical aspects and also on risk assessment aspects, and also the working groups, of in this case groundwater, but it will be also for the surface water will be the chemicals working groups will be involved and consulted on this process. And then will include different data, but the analytical methods to be included for each substance. So the need to for each substance that we put in the watch list that there is an analytical method there. So that's kind of guidance. And then we manage as well to put in the watch list with the kind of conditional antimicrobial resistant elements and microplastics. But this is conditional, as I said, to that there are methods to monitor, reliable methods to monitor these pollutants. As we know that they are difficult. Please, next slide. So groundwater. So this I go now to Annex 1 and 2, as you remember I mentioned before for the groundwater directive and the elements that we have managed to incorporate in these two different annexes. So pharmaceuticals. We managed to include 3 individual pharmaceuticals: carbamazepine, sulfamethoxazole, and primidone, not with the quality standards that we wanted before. It was 10 times more strict than those ones that I showed here, because considering the sensitivity of the groundwater ecosystems, but member states or the council didn't see this because of the administrative burden, didn't see this very keen, and then the 10 times was released, and then it's like, as you see here, the thresholds 2.5, 0.1, and 2.5. We also wanted to introduce a total pharmaceutical standard. It was not accepted, so this really lies out. And then we have included a provision about following the groundwater ecosystem. So and then at the end it was like, okay, not in all the aquifers, not in all the groundwater bodies. We know that we have these kind of organisms, but in case that some aquifers like the karstic normally, the member states identify that they have these kind of ecosystems, then a more stricter values than the ones that are here for the pharmaceuticals will be applied at the freedom of the member states. This is also out of the directive. PFAS, we suggested a list of 24 PFAS, linked to the relative potency factors, It was not accepted, mainly because, this will make more strict groundwater compared to the drinking water, and there was some kind of disagreement with this from the member states. So the 24 PFAS that the Commission suggested remains, added to TFA in the surface water, in the EQSD, but not in the groundwater directive. The groundwater directive will take just the 20 that are already now in the drinking water directive, but we managed to put these 4 that is coming from an EFSA opinion, at EFSA dossier, that are the ones that are more concerning. This has been included with a quality standard of 4.4 nanograms per liter. And then the TFA, that we know is a little bit special case. It's still there because it's considered a relevant metabolite of pesticides, and then it's already in Annex 1 from in pesticides, so 0.1 milligrams per liter. But it will also be considered in the future review of the groundwater directive. Please, next slide. Just maybe I'm gonna go through very quickly on this. So the pesticides and the relevant metabolites were already there in the groundwater directive, but there are another subclass of these that are, as you have heard, the non-relevant metabolites. This is also a very difficult and controversial topic because it has been difficult to assess which ones are relevant, which ones are not relevant. So the first thing that they have to mention is the second point, on the pesticides. So member states wanted a clear division between what is relevant and what is not relevant metabolites. Okay, and this is something that's a homework for the Commission. And then we managed, after the negotiations, to include the non-relevant metabolites, individual and totals, with 1 microgram liter, 5 microgram liter, and then with a clause, well, there is a range, and with a clause, if there is submitted evidence from the member state that there is no ecotoxicity, then the highest threshold will apply. And then others like trichloroethylene, tetrachloroethylene, also added to Annex 1. And then, maybe this is the most important. Commission was, as I said, this is a very technical file, and we have to discuss every little single pollutant and also link it with the toxicological effect or the toxicology. We wanted, the Commission has the idea that little by little start introducing groups of pollutants so that they cannot be substituted so quickly. So start legislating by groups. So there is a first attempt now in this proposal that there is effect-based methods. Now we will start with these estrogens, pharma estrogens, but in the future revisions is the second point, and the others. So there is an obligation in the next revision to include sums and totals for these families. Bisphenols, pharmaceuticals, pesticides, PFAS. This is included in a new added annex of this revised directive, and with the idea that we'll discuss this in the future revision. Please, next slide. I know that probably I'm out of time, but I just wanted to introduce the working group of groundwater. So we In parallel to the Water Framework Directive, we have this structure of the common implementation strategy that are a hierarchical structure agreed on top of the hierarchy water directors, the strategic coordination group. But then in green you will see all the different expert groups that are meeting at least twice per year, in which different tasks with different normally the objective of these groups is to make guidance which are not legally binding, but it's a guidance so that members can follow, also make reports and to discuss important issues. And you can see that we have one in groundwater working. Please, next slide, and just want to show here a little bit some of the activities we are going around. We are doing a watch list. Of course, this is the most important activity. But then other issues like managed aquifer recharge. We recently last year we issued a guidance on this, and then discussing links with the drinking water directive, links with what happens to aquifers in the context of climate change. And some how well the member states are interested in saying, okay, because of the one out all out principle of classifying the water bodies, they are interested in following just one single pollutant and see, okay, if there is progress or not, and try to show it in the river basin management plans. Next slide, Arthur, maybe I think this is the last one. Okay.
Thank you very much, Isaac. Thank you very much for joining us then over the phone. I'm sure it's not as you normally do it. So thank you again. Thank you for our two speakers ahead. I think you can just quickly come back with us and switch on your camera. I saw that in the meantime, as Isaac said, like we are running out of time. We are almost in the last 5 minutes. Kai and Cornelia, I saw that you replied to some question in your chat. So I don't know, do you want to add maybe 1 point? Otherwise, we will take the last one in a Q&A as you prefer. If you want to clarify something that you say in the chat.
I think the general questions we already answered in the chat. So that's fine for me.
Okay. I think Cornelia, I think Kai, I think the question came up when you were talking, but you had someone that asked if you could please share an experience you have had to overcome siloed mandates of various agencies working on groundwater management. As I think you mentioned it or flagged it as one of your main points, or Cornelia as well, if you want to share something on this.
I saw that bringing those people together actually is the first step and very important. We saw this in Linz when we had meetings with really multiple stakeholders. This was a first important step, I would say.
Yeah, I can agree about that. What we did, so we are from a university, but we had some projects in cities, quite in a few ones. And what we did here is, of course, we tried to invite all people from a city administration from different departments for a seminar, for a step seminar we call it. And what we experienced here, also outside the city here, who's dealing with groundwater issues related to the city. And what we realized is that even the inner city department dealing with groundwater, they haven't talked to each other before. They met at this seminar for the first time about this issue. That was quite wondering, I would say. So, of course, they were not aware of that the other department has also data of groundwater and so on. So I think that's the main lack, what I tried to explain, that there's even not the knowledge, but the challenges what we have, there are actually interdisciplinary between the different departments. And this is why I think my vision would be that there is a central groundwater management position in cities dealing with this data and exchange with the different departments who cannot care about that, even if they have just a slightly connection to groundwater, then there must be a central person or whatever, because I think the challenges will become more and more and more, and groundwater is just such an important resource that we cannot actually not care about that with the main focus. That's my, yeah. So, but of course, it's a hard work, and if you implement in a city the connection and try to engage the people working in the city with groundwater to exchange with each other, then this is a starting moment, I guess.
Yes, thank you very much. I think I can only agree. Even though today we do it online, at one point you need to put everyone physically in the same room and to exchange and to get to know each other. It's key to success. So I think I can only agree with you, what you said, both Cornelia and Kai, on this. Okay, I think so. Again, you took, I think that was the last questions. You took the one in the chat. So thank you very much for taking the initiative on this. Otherwise, we'll have a couple of people that would have been frustrated. Let me quickly reshare my screen, but we are coming to the end of our today's webinar. So thank you again to the speakers and for you, the participants, and for your questions and lively discussion on the chat as well. You will receive the presentation. Today's webinar has been recorded. It will be uploaded into the EWA YouTube channel as well. And please visit the Margin website, or any of the Margin partners that will have information on their website as well, to keep you up to date of upcoming events. You can also have a look again, EWA website as well, or our newsletter that you can register and receive updates. I know we have a Climate Alliance Margin webinar in February. I'm sorry, I just have to check, of course, the date because I forgot it to add it to my notes. Otherwise, it's too easy, you know. And it is, Janina, I'm not sure when do I have it. We have it for the 24th of February on resilient municipalities safeguarding groundwater and soil in the face of climate change. And it's organized by Climate Alliance, another project partner from the Margin meeting. And again, thank you very much to everyone. And once you will leave this room, you will see a short survey. So please take the 2 seconds to fulfill it so we can get your feedback. And Caroline nicely just put in the chat the link to the upcoming Margin meeting in February. So thank you very much again. Thank you, everyone, and have a good day. And we hope to see you then for the next Margin webinar. Bye-bye.
Thank you.
Bye. Thank you.
Yeah. Thank you for the organization.
Okay, we